Objective of this video is to explain the doubly reinforced rectangular sections. Now the ultimate moment capacity of MU for doubly reinforced rectangular sections. Why we need this doubly reinforced beam? When the applied moment, when you calculate the M star value using the structure analysis, and that's the capacity of the beam. When the M star value, so this is M star, so this one is M star on the beam is more than the moment resistance. So when M star is greater than the capacity of the beam, in that case the structure engineers has three options. We can't use these cross sections because its capacity is lower, it cannot carry the required moments. So we can increase the depth of the beam. We have an option, let's say this is singly reinforced, we can increase this depth of the beam. Another option is to use higher grade of concrete. Let's say if we want to increase, let's say we use 20 megapascals first, and then we can increase FC dash, let's say 32 megapascals. That will increase this capacity. So another option is to increase the capacity to improve the reinforcement in the compression zone, to increase, or another option is that we can add some reinforcement in the compression zone. So that's the case when you have, generally speaking, with this capacity should be greater than this M star. If this is not the case, then we have these three options. Now among these three options, if you let's say why among these three options, that let's say when you have a not possible to increase this T. So first options that possible, that architecture don't allow to increase the depth of the beam for various reasons. The first reason is that, okay, let's say they want to increase the room in the headway rooms in that one. Another options that we may need to use this doubly reinforced when you have earthquake loading, where is the reversal stress. Reversal stress generally not applicable for the singly reinforced and is a precast beam. Some restriction also, we cannot use sometimes that the concrete compressive strength has been restricted, so we no need to, if we don't allow to use increase, the only the option left is to input the reinforcement in the compression zone. So that increase in the compression zone, that will is the doubly reinforced. So in that case, if you have a M star value, which is the design moment, which is greater than your capacity, we cannot use the singly reinforced beam. In that case, we just need to increase the capacity of this capacity 5 mu by putting the reinforcement in the compression zone. Now this type of reinforcement in the compression zone, we name them doubly reinforced beams. So what happens in the previous examples, we are generally have the reinforcement and let's say this is tension side of the beam, this is compression side of the beam. When you have sagging, for examples, when you have beam in the sagging, so when you have beam in sagging, so this bottom portion is in the tensions and compressions, and we are providing reinforcement in the compression. So this is the typical singly reinforced beam. But now let's say for this case, if we come up with the say that 5 mu is not enough, the capacity is not enough, comparing let's say this is M star value, then in that case we need to put this extra reinforcement in the compression side. So this is a typical diagram. This is depth B, and we need to calculate this DSC from the cover to the top center of the compression reinforcement. Now just want to check some fundamentals, that what is the difference between singly and doubly reinforced beam. For singly reinforced beam, we have generally the reinforcement at the bottom and we have anchor bar at the compression, but in the doubly reinforced we have extra reinforcement in the compression side. This is the area of the compression reinforcement, area of the tensile reinforcement. Now in the tension, for this case singly reinforced, AST is provided, where AST, so we just provide the reinforcement in the tension So this is tension side, this is compression side, and this is the hogging case. Hogging case meaning that the beam is bending in these fashions. So in that fashions we have this neutral axis, this is tension, this one compression. But here in doubly reinforced we are providing additional ASC that we provide to increase the capacity. Now in compression zone we have anchor bars, but these anchor bars are not carrying any compression force, unlike we are providing this reinforcement in the doubly reinforced where this ASS is resist the compression force. For this case, capacity of the beam, which is the capacity of the beam, is greater than the mu, so that is okay. It's a good. But this in this case, generally this case applied when this condition is reversed. Let's say mu as m star is, if you are predicting this one, then we need to move on this doubly reinforced. 5 mu bending capacity is less, so as I mentioned, this capacity is less than the design one, and we increase this 5 mu, it has more value because of this additional reinforcement. Ductility is less because the reinforcement compared to this doubly is a small reinforcement, and this ductility is more because we have additional reinforcement. This is not suitable for earthquake like a reversal load, but this one is suitable for reversal load. So that is the quick overview on doubly reinforced concrete beam. Thank you.